Welcome to our presentation, Nurturing Math in Infants, Toddlers, and Twos.
And we're talking about the precursor concepts are all around. Hello, my name is Jackie Chen. I'm from Erickson Institute.
And my name is Lisa Janae. I'm a colleague of Jackie's at Erickson Institute in Chicago.
Lisa, I know you took lots of pictures, but one of this is all of your objects. And what do you try to do with all these objects?
I was thinking about how I could sort them. And one way I thought about sorting them was making just two groups in answer to a yes-no question.
Oh, so what is yes, what is no?
Well, the objects on the left are all things that I can ingest. They have something I can eat or drink. And the objects on the right, it's no, they do not have things I can eat or drink. So can you think of some way to...
That's a very interesting way to sort projects. How could we resort this collection? Do you have any idea to resort?
I don't know. Do you have any ideas?
Sure. Yes, I do have another ideas. Oh, okay. Here we can sort them based on the function of the objects. In other words, and the left group is an object for communicating ideas. Middle group, objects are for caring for the body, such as drinking, eating, and smoothing and soothing the chapped lips. And the right groups is an object for doing things to other objects, such as unlock the door and clean the glasses. I know you have lots of ideas. Can you sort it another way?
Yes, I sorted yet another way. I thought about the shape of the objects. So on this time on the left are the things that are cylinder-like, not all exactly perfect cylinders, but they're all like cylinders. And in the middle, they're rectangular-ish, all have four sides. And on the right-hand side, they didn't fit exactly one thing. I called it my miscellaneous group.
I see, you're really flexible thinking, okay, in the sorting. Can I sort one more way?
I don't know. Is there one more way?
Let's see. Oh, here, yes, the color for the objects. On the left group is sort of a red, orange-ish, and the middle group is a silver and metallic. And the top on the top right is a blue, and the bottom right is a purple. So
yeah, you'll notice. Yeah, you'll notice that I have more purple things than anything else because I love purple. And if you guys, the people watching this, you had your own objects or this set of objects, you might come up with some different groups. But my question, Jackie, is how is that taking a bunch of stuff and making different groups? How is that math? We're supposed to be talking about math.
That's such a good question, Lisa, because in our project, we defined math in a way that says math is a logical way of thinking that allows for increasing precision. So in this sorting activity, we use mathematics as a tool to make sense of the things that you have. And we use math to help solve the problem, saying, okay, and I use this bunch of objects to do this, and the other bunch of objects to do something else. So this is math. Right. But how does this relate to our wonderful teachers and infant and toddler teachers?
Right. I'm wondering if infant toddler teachers, if they've ever said something like this to a 2-year-old. This is a question I would ask. Have you ever said, I just got your bottle warm, just right to be yummy for your tummy?
And I know, and when we go into the classroom and we hear teachers saying that, which ball do you prefer? The bigger and the bouncier one, or the smaller one that is easier for you to hold?
Or maybe you've said, first you washed your hands, now we have lunch, then we go outside to play. After that, it is nap time.
Okay, well, today in Chicago, it is such a beautiful day. And the kids, let's go outside instead of playing inside like we usually do.
Yes. So, in all of these ways, you're providing your little ones with an early math experience and nurturing their mathematical thinking using precursor math concepts. All those pink words in those sentences had to do with the same kind of logical mathematical idea.
And Lisa, you use a term that is new to many people that is called a precursor mathematics concept. Can you explain that a little bit more?
Right. Well, the one that we've been using is about attributes because we were talking about the attributes of the objects when we were looking at the pictures, and then the sentences that teachers might say all had attributes in them. It's yummy, it's warm, we're inside or we're outside. So these are properties or qualities that allow us to describe and classify the world around us. Attributes. This is one of our precursor math concepts.
So then, and with this precursor math concepts of attributes, and I see here we also define and several key ideas and describe our attributes. The first one, we see we perceive attributes of the world around us through our senses. Secondly, we talk about attributes can be used to help us group the projects around us. The third one, we talk about the language. Language allows us to describe attributes with increasing precision.
So
can we really go through one by one to help people to unpack these?
Let's unpack this first. Yes, Jackie. Let's first unpack what we mean by precursor concept. A precursor is something that comes before and prepares for or signals something. That's just a sort of definition of the word.
Oh, well, that's a wonderful definition. Let's look at example in child development. And I think for infant and toddlers, and the teething is one thing that we all as parents and teachers encounter. And the children have first and this kind of precursor signs like drooling, irritating gums, and they're crying. And what is that?
It's the precursor to the teeth coming in. It's not the teeth coming in quite themselves. It's a precursor to the teeth erupting. So it's signaling that that's coming. So that's what we mean by precursor, something that comes before and signals something that's going to come after. And
so are you saying that an attribute is that kind of a precursor?
Exactly. Attributes, one of these precursor math concepts, and we're going to look at it a little bit more. You remember when we first said this, we said there were these key ideas. So the first key idea is that we perceive attributes of the world around us through our senses.
Okay, I see you have a list of senses here. Look, taste, smell, feel, and the sound. How does that relate to the attributes of this picture, apple?
Right. So you see a child who has an apple. So the apple might look red or yellow or green or multicolored or speckled, round, shiny. Those are just some words. And it might taste sweet, tart, sour, spicy. It might smell fruity, piquant. It might feel smooth, crisp, hard, soft, wet. It might sound loud. It might sound crunchy. There's different ways that we can describe how we're sensing it. And these are all attributes of the apple. We're perceiving with our senses.
Yeah, Lisa, this example really helped me to helping me understand and how these attributes is and perceived through our senses and the 5 different senses, and you get understand all these attributes about this apple.
Right. So then here's the second key idea, that attributes can be used to group.
Okay, I see here lots of baby finger foods. And how could we group these finger foods?
Right. Right now they're each in their own group of the same food. So someone grouped them for the picture, all the little pieces of peaches with all the pieces of carrot, so they grouped them just by the same thing. But we could do other groups.
Okay. Oh, I see one way we can group is by color. for instance, and then we have a raspberry, strawberry, that's red. And then we have a peas, avocados, edamame, and zucchini, and that's green, and so on and so forth.
Right.
Any other ways we can?
Right. We could do texture. I was thinking that mangoes, bananas, tofus, and avocados were all mushy, and cereal and carrots are both crunchy. So these, again, they're examples of how we can use attributes to group, our second key idea. Now we're going to move to the third key idea.
This third idea is talking about the language. And language allows us to describe attributes with increasing precision. So here I see these, we have pictures of crackers and blocks. How does language help us?
So crackers, we can just say there's crackers on a plate. We can call all of the crackers round. They all have holes. They're all white and beige. So those are all different ways to describe it. We could try to get more precise about the different crackers, that there's a smallest one, a largest one, and one that's in the middle by size. And there's one, you might not see in the picture, but one has words printed on it and two of them don't. And one is puffy looking and two are flatter. So there's different ways we can be more precise other than saying we have 3 crackers on the plate. And that, of course, is another way we can describe them, that we have 3 of them.
Wow, that is certainly give us a much more precise understanding of these crackers. Now think about the same token, we can talk about the blocks, we can talk about all cubes, all pile, all painting, and so on and so forth, using all the language to describe this pile of blocks as much as we can based on their attributes.
Right, and each pile has its own attributes, and then we had 3 different piles that have different attributes, and we can be different ways of describing them. So there's a lot of ways we can be precise, and it all depends on what we're interested in talking about. So those were the 3 key ideas under that precursor math concept of attribute. But we also want to think about attribute is not just something we're thinking about with very young children. We do, and it's one of the things people think about from their very youngest ages, but it becomes an important part of math from birth to kindergarten and even beyond. Attribute really is an important part of the math that people are doing in college and professional mathematicians do. But let's just look a little bit at how this precursor math concept about attributes being properties or qualities that allow us to describe and classify the world around us turn into some big ideas of early math. So what do you think?
So Lisa, I think here you try to help all of us to see the bridge, why we call this precursor, and they are preparing us to learn about a more mature concept of mathematics, correct?
That's right. So I listed 4 of the big ideas of early math that we've explored in our work at Erickson, thinking about the math of children 3 to 6, preschoolers and kindergartners. The precursor math concepts, those are the math thinking of children who are infants, toddlers, and 2s. And of course, math keeps going after kindergarten, but here are these 4 ideas that preschoolers and kindergartners are going to think about. And I'm going to keep moving in the slides because we have a slide about each of them to talk a little bit more about it.
Okay. So now this is the first one, and we'll see that, and we're talking about, and attributes can be used to sort collection into sets. Okay, here I see several children working with teachers, probably they are trying to sort these objects. And so how can we call these different objects and the different groups?
Hopefully you can see the numerals that we put on the picture. There's a 1 and then a 2 and a 3 and a 4 on top of the picture, because the children had already made the groups and the teacher was asking, what can we call these different groups? And this is what the children came up with. Group 1 is things that are round. That's the one that the teacher's hand is on. Groups 2 and 3 are on the other blue piece of paper in front of one of the children. Group 2, the children said, were things that are long and straight. And group 3 were things with holes. And then group 4, which is sitting on the table, were things that are light brown. And
that's really, yeah, these are those round, long, and the holes light brown. those are attributes, right?
Exactly. They're
Okay.
attributes that those children have used to sort. And I've always thought it was, I was not in the classroom with these children, but I always wonder if the things that are light brown are on the table because the table is light brown. And so the children didn't want to put them on a piece of paper. I'm not sure, but I've always
Oh,
wondered
that's
about that. Were they
interesting.
thinking of the attribute of the table when they left that pile on the table?
But I really see now and why attribute is so useful a concept for
Right.
children to use, right? And here, and the sorting activity is certainly lots of happening in the classroom, in the preschool and the kindergarten and up.
Right.
That's
And
why.
we sort our clothes to put them away. We sort the objects in the classroom. As you get older, you need to think about sorting things into groups to think about scientific ideas, or we sort into different kinds of shapes or different kinds of numbers as we do higher math. It's not just like, oh, here's a fun bunch of stuff and let's see the groups. We really use it as we continue to organize our world and make sense of it.
Yeah, and Lisa, as you said, this is not just in the school math, and actually in the life and the mathematicians and scientists using certain things too. For instance, if you go to any lab, and those and the gadgets and the machines and equipments are always sorted based on some kind of functions, or
And they
right?
couldn't use them otherwise. So let's
That's right.
go on to this second big idea that we had pulled out, that quantity is an attribute of a set of objects. What does that mean, Jackie? How can quantity be an attribute? We've been talking about things like color and texture, and what do you mean quantity is an attribute? That seems so
Well,
strange.
yeah, again, it's really, and we usually just see number 1, 2, 3, 4, 5. Okay, good luck. Now that is quantity. But why quantity is an attribute? Because let's look at this picture. And here we have three elephants. They obviously look much bigger if we compare with these three mints. Okay, but when we look at attributes of a size or weight, elephants are much larger than the mice. But for the attributes of quantity, these two sets are identical. Both are sets of three creatures. So in other words, and Lisa, earlier we see color, okay, we see and the brown and the elephants and the yellow mice. And here, three is also something to define these two sets. That's why we call that as also attributes.
Right. And it's the same attribute as how many fingers I'm putting up in front of my face right now. There's that three can come up many, many places, and understanding what's the same means that someone understands that quantity is an attribute.
So
And of
can we
course,
see in this case, these three is like an adjective, define the collection, define the objects.
exactly. Quantity is an adjective to describe a group, is one way to think about quantity. So that's that next big idea. And then here we have another one, that many different attributes can be measured even when measuring a single object.
Wow, that is a complicated concept. Okay, now we have so many jars here. The question you ask here is, which jar is big?
It all depends on what attribute you're looking at.
Oh, really?
What kind of big is it?
Huh.
What attribute are you comparing?
So when we ask a big, that depends on attributes we're asking.
Right. Are we asking which is the tallest? Are we asking which is the heaviest? Are we asking which is the widest, which holds the most water? There's so many ways we can describe the size of something.
I
So,
see. Here you listed the height,
right.
weight,
And
capacity, and circumference. All these are attributes. Even we measure just a jar, but it depends on attributes. The definition of a big would change.
right. So nothing is big in and of itself. It's big in some way, and it's big in comparison to something. the tallest jar of these sets of four is not the tallest jar in the world. It might be very small compared to some big jar in an industrial kitchen, right? It might be still the
Yeah.
small jar, even though it's the tallest jar here. So there's, we have to think about what kind of big we're thinking of and then make some comparison to decide what's big in this situation.
I really can see that's mathematics. Here, we also talk about the shape. A shape can be defined and classified by their attributes. Can you explain a little bit more about this?
Well, there's four triangles we're showing right now, and the attributes that make a triangle is that it has three straight sides and three corners, three straight sides that touch, and you can't quite do it with your fingers, but three straight sides that touch and you get three corners. So these are all triangles, and preschoolers can really grasp that, but sometimes they might have only seen triangles of a certain kind and pointing a certain way. This child here is looking at how a triangle is the same even if you look at it upside down, and says it doesn't matter which way it's turned, it's still a triangle. Because sometimes kids think it's only a triangle if it's sitting flat on a bottom and pointing up towards the top, but that's not true.
So when you see, Lisa, that's why I think the definition you gave about shape, the triangle, based on their attribute will help a lot. That's why, and it doesn't matter which way they turn around, and as long as they have three straight lines and three corners, they are triangle, right?
And that's the beginning of really much more complicated geometric thinking that people can do when they're older in high school. But we also, what is a triangle means we have to think about what's kind of a triangle, but not quite. And again, this is not, maybe not get into this really heavy with your preschoolers, but sometimes you might say, oh, this pizza, it's a triangle. And you don't want to be upset about that. Yeah, it's got three sides. One of them's curved. So it's almost a triangle. It's not a math triangle. It's a food triangle, but maybe it's not a math triangle. So to recognize that children are seeing three sides, but then also help them sometimes get back to that real precise mathematical definition, they have to be straight and they have to have pointy corners, so that we talk about almost triangles as a way to help really understand those attributes that define triangles. So these are just some of the ways that attribute thinking of infants, toddlers, and twos becomes much more mathematical thinking as children get older.
I see. So now I see, and what do we mean by precursor concept? And in mathematics, precursor concept is an understanding or ability that underlies or prepares the ground for the mathematical big ideas that develop in the early school years, and particularly in the pre-kindergarten and the up. And I think that all the examples we have just talked about help us understand why precursor concept, mathematical concept, is important. It starts from the infant and toddlers and the twos.
Right. And we like to think about there being these three parts. That's our little diagram here, that there's the what we've just been talking about, what the math is, understanding, thinking about attribute. But then there's also who, thinking about the children that are doing the thinking, because what a 1-year-old is thinking about attribute is very different than when it gets to being a 5-year-old thinking about attribute. And then there's the how do we engage the children in thinking, the engagement in our teaching strategies as the adults working with children. So there are these three parts of it, and in the middle of it is that precursor math. When we've put together the what and the who and the how, then we're really in the world of precursor math.
I really like this diagram. So let's look at it, and the first and the what, the content knowledge. And we have in the early math collaborative, we have identified 4 precursor math concepts. And Lisa and I just talked and more in detail about attributes, but we also have a comparison, change, and the pattern. All these 4 precursor concepts, precursor math concept contributed, associated, and help and the preschool and primary math concept areas. And here we made a few lists, and such as sets and sorting, patterns and number sense and counting, number operations, spatial relations, and spatial reasoning and shapes, as well as a measurement and the data analysis. and then these are very well connected. And then we have a book here, and it's called the Precursor Math Concepts, and that described the connection between the precursor and the more mature mathematics big ideas.
Right. And so this is what we've spent most of our time talking about so far, is this what, thinking about what the math is. We're going to spend a little bit less time, but a bit of time right now talking about the who and the how. So the who, child development, infants, toddlers, and twos. So children from birth to age 3, we think of them in these 3 stages, and it kind of lines up with those 3 years, but not exactly. And we talk about those, the youngest infants in being in the emerging stage of precursor mathematical thinking, that, and their main driving question for them is, what is this? And then as they move into that toddler stage, they're developing, building, taking more of it on themselves, and that the driving question for exploring the world is, what can I do with this? And then as they get up to being 2-year-olds, moving up to 3-year-olds, they're transforming, really being able to become more precise and make more use of this thinking. And what can I make with this is their driving exploration question.
And I think, as Lisa said, and these 3 stages are overlapping. They are not just we finish one stage, then we move to another stage. That's one thing I think we want to emphasize. The second thing we want to emphasize is the individual differences. Here we talk about the general trend, but it depends on the child's proclivities and the environments and the experiences, and the child, and each individual child certainly is different, and also depends on their experience with particular materials and the task, and that also can vary child's and developmental and the kind of and the performances.
Right. And this logical mathematical thinking, that using ideas to make sense of the world, using an attribute to understand which thing is going to be easy to chew and what's going to be hard to chew, or those older children, what can make my blocks stack up and what blocks won't stack up, that kind of thing. As you come up with a new problem, you might go back a little further and have to think about how to use the logic, and as you get really experienced with something, you can become more precise. So it's so many ways in which we keep thinking about this moving. Any new idea has to merge and develop and transform. But children really go from do a lot of development of thinking. They're doing a lot of thinking when they're babies, but gosh, by the time they're 3 and they can talk, woo, really gotten very far. But how do we help it, Jackie?
We turn to and the how, the third circle, which is and more about engagement and the teaching strategies. And here in our project, we develop and so-called care principles. And the care means closely attend and intentionally response. And we feel that, and the caregivers, if you use this care principles in way that are appropriate for the child's age and developmental stages, and the children will grow and develop mathematical competent, and the children and the child and the adults.
Absolutely. So let's give
it in, Lisa, and some specific examples. How does that care look like in daily routine in the classroom?
Exactly. So I think that it's important to think closely attending and intentionally responding isn't only about math thinking. It does really help develop it, but we hope it's the way you're interacting with children always, whether you're thinking about mathematical ideas or something else. But it means we're watching what they're watching, we're watching what they're doing, and then we're interacting with them. So you can see in this one picture in the bottom here, there's 2 adults and a child with a ball. And right at that moment, it looks like the ball's going back to the child, and maybe there's been back and forth, and the adults might say, "Oh, that round ball, it really rolls. Coming to me, going back to you, going to Auntie," just describing what's going on and helping the child attend to the roundness and the rollingness of the ball might be a way that we are closely attending to their interest and intentionally responding.
I think similarly, and when the father is working with the son or the child and on the block, and it's the same thing. Wow, this is a fall, and can we build a taller? And can we build a wider? And does this fit? In other words, I think Lisa made a very good point, and this care principle is not just for mathematics, but what it says that math in the early childhood is a part of a life. When we really use this care principle in children's life and care about the children, and we naturally embrace and include mathematics ideas and activities in the daily routine.
And it's not only about playing. We might also be changing a child's diaper. And maybe as we're going over, they're kind of fussing, like, oh, yeah, that diaper, it's really wet now and it's uncomfortable because it's wet. All right, we're going to get you up on the table. Now we can take off that wet diaper and get you a dry diaper. And we're talking through and trying to keep them engaged, but we're also helping them notice different attributes that are part of their day-to-day life. So we have an example here of an adult and a toddler who are exploring the math all around. They're thinking about attributes. So I'm going to go ahead and we're going to play this little video for you, which you can also find on our website. So if you want to watch it again later, you'll have a chance.
Look, Uriah. Look what I have. See the avocado? Yeah. We cut the banana, but we're going to peel the avocado. We're going to do something different to see what's inside. Here, would you like to help me peel it? How does that feel? How does it feel? It's kind of bland, Uriah. Now my hands feel like there's lotion on there now. Were you trying to put it on my face? You trying to put it on my face? You think it's lotion? It does kind of put you in the mind of lotion because it's smooth and it's moist and it spreads around on our hands. Yeah. So, Uriah, I found out that you don't like avocados. You don't like the taste of avocados. But your favorite is oranges because you ate all of it. Yeah. Would you like another piece of orange? Oh, no, you're interested in this avocado lotion that we just made, huh? What does this remind you of, Uriah? Maybe when you lotion your babies in the dramatic play area? You take care of your baby dolls? And I let you put lotion on them? What? What are you doing? You gonna bring your baby to the table with us? Okay. Oh, you're putting some avocado lotion on her face and her hands? You think baby like that?
Wow. So, Jackie, what did you see that adult doing with that child? Was that adult closely attending and intentionally responding?
Yes, and certainly, and she's using all these care principle and actions. For instance, she really interacted with child, observed child carefully, and describe what the child is doing. Oh, you're really mushing this, and you're trying to use this as a lotion, and how does that feel, right? And Lisa, what did you hear about the positive conversational tone and she used?
Well, she was responding to what the child was saying and didn't immediately react in any sort of negative way about it. This started out as a taste test, and then the child started, playing with it, which it did certainly feel like lotion. And sometimes people might have gotten upset about that. And been confused because they thought it was going to be, they tasted the banana and they tasted the orange, and we didn't have that part in this video, but they probably were talking about the taste and the color like you'd think with the food. But then this time it starts to be about the texture, and the teacher keeps responding and being positive, like, oh, well, you have an idea. Let's see what happens.
Yeah, I agree. And I think the teacher really and follow the child's lead but also guide the child's action in the sense that she doesn't name attributes or child's,
Absolutely.
right? So it's like a moisture and the smoothie and things like that, right? And do you remember any other attribute names she used?
She talked about how it's smooth, it's mushy. At the
Mushy.
beginning, she talked about how it was bland, but it was interesting how the teacher had words to describe, and some was attribute language and some was just description of the action, less of an adjective, but more like, oh, you're rubbing it around. It's going around, it's going on the
Yes.
hands, but they didn't try to take it back to, so is this sweeter than the orange, or is this, what color is this, and it's a different color than the orange. It what became the teachers adding attribute language to what the child was doing, and not trying to force the child to go back to the attribute discussion of comparing the foods that is where they started the whole conversation.
That's good description of what the teacher has done. And I also see teacher make connections to child's prior experience. And I think this child went back to the doll, and the dramatic play area was the doll, right? Because they were playing with doll before. So, and the teacher make a connection saying, okay, and you want to do something with the doll? And she did, right?
Because it looked like they had like empty little lotion bottles for playing with the baby. They without real lotion in them probably, but they pretend, because the children, they get lotion on their hands, they might get lotion on their face, especially in the cold in Chicago. They might get lotion when they get their diapers changed, if they have diaper rash. That's part of the child's world, and so there was that connection made, and it was clearly coming from the child, and then the teacher extending it and helping them. And as you say, a lot of this does have to do with language. A lot of these things have to do with language.
So let's look at the language. My goodness, and there here you made a long list of different languages that relate to the concept, related to attributes, concept, quantity, magnitude, size, sensory perceptions, and so on and so forth. So let's look at the quantity first. Here, and what we have here says all the cardinal numbers, 1, 2, 3. And I remember before we talk about attributes, quantity is an attribute of to describe and the collection of object. And here we talk about the cardinal numbers. And can you see a little bit more about what does that mean? How does that relate to attribute?
Well, because when we were talking about the 3 mice and the 3 elephants, that's a cardinal number. It's describing how many. And so you're helping children think about attribute when you say, oh, there's 3 friends at the table and we need 3 apples for the 3 friends. We're helping them understand how it describes the set, as opposed to just memorizing how to go 1, 2, 3, 4, 5, 6, 7. You do need to learn those words, but to understand what they mean as attributes. When kids get a little bit older and they actually put on gloves, it's like, oh, I need, 1 place for each finger to go in the glove. They're thinking about that 1-to-1 correspondence of their 5 fingers into the 5 things of the glove. So
in other words, and then knowing these cardinal numbers really help children develop a number sense. And then later,
right. When they're infants, toddlers, and twos, we're not spending a long time making sure they can repeat it back to us. We're just using it in an appropriate way to describe the world. Like, there's 2 children sitting here and I've got 2 books, 1 for each of you. You're just saying it and using it. And like I say, there's a lot of examples here, and hopefully you got the slides that we provided with this presentation, so you can use this as a jumping off point to think for yourself, oh gosh, how many different attributes, words do I use? Because using more words helps children focus in on attribute and be able to use it more logically. Not that we're just counting how many words by any means, but we're trying to think about when can we use them that help children make sense.
Well, Lisa, I do have a quick question. And I hear from parents sometimes they will say, well, kids cannot see it yet. Why should I really always keep talking?
Well, it helps children make sense, and it helps them be ready to talk more when they can. But it's a delicate balance, and that, like I say here, is layering language onto an experience helps children make sense of the world. But we sometimes also need to be silently paying attention to the children. You don't want to be talking so much that they can't think. So it's a balance. But our talking when they're little is helping them make some sense of the world, and that's why we have to be paying attention, so we're talking about stuff that makes sense to them. They get a lot less of our having a conversation with our friend while they're playing. I mean, they hear stuff and could be useful, but it's not helping their thinking as much as when we're talking about what they're doing. And we can also use books as one really great way to harness more precise language, and it's a shared experience that we can keep going back to that same book and talk about it. The rest of the world keeps changing every day, what's for dinner and what's for lunch and what it looks like outside. But this book, it has the same pictures every time I go back to it. So I can get more and more precise and have conversations about that same thing. And I can look at the same book that the other child looks at, or that grandma and grandpa have at their house, or whatever. There are many ways in which the books can help us really hold
Yes.
that language
Book,
piece.
because a book and the for young children all have pictures that certainly and what is it, and help children to have a shared kind of a point attention, shared attention, the shared point of reference, and to talk about things, right?
Yep,
Yeah.
absolutely. So this has been an extremely brief introduction to our precursor mathematical concepts. The what, we spent a little longer on the what, only a little bit on the who, because we think you know the who so well if you're spending all your time with infants, toddlers, and twos. And we spent a little bit of time also on the how. How do we engage children and help them
Well, we
develop
certainly
their
hope
thinking?
that it helps this brief conversation, and it will help you start thinking about how to nurture mathematics thinking in infants, toddlers, and twos. And it can be developmentally appropriate, and can be engaging, and it can prepare children to move and forward for their more mature mathematics development.
So if you have questions or comments, feel free to contact us. Like I say, hopefully you've got the slides and you can read our email addresses and use them. And you can also check out our website, earlymath.erickson.edu. Thank you very much for your attention.
Thank you.